Thank you. Okay, we are going to talk about 2.3 today, which is graphing equations of lines. And we're going to do it without making tables today, so that you don't have to show me as much work, right? Because we know that if something is in, we know the equation for a line is y equals mx plus b, right? So now we're going to use that knowledge and graph our y-intercept, and then count with the slope and make another point and graph a line through it. Cool? Make it much simpler than making charts for me, or spend less time than making charts for me, okay? We are going to talk about lots of parent functions this year. You need to get familiar with that term because you need to know what a parent function is. A parent function for a linear function is in the form of f of x equals x, okay? F of x equals x, okay? So it's very simple, okay? Any type of, it's the simplest form of that function. So the simplest form of a line is f of x equals x, okay? Let's see here. In general, your y-intercept of a graph is the y-coordinate of a point where the graph intersects the y-axis. So the reason why f of x equals x is the simplest form is because what would be my y-intercept in this case? Is there a b on this? So my y-intercept would be 0. So it's going through 0, 0. And what is my slope technically? What's in front of that x technically? Oh, 1. And so we go up 1 over 1, up 1 over 1. So this is the simplest form of a graph of a line. Okay? We're going to do lots of graphing today on the examples. Cool? So we are going to start by graphing these equations. And like I said, you're going to pretend that everything is perfect for me this year when I go to graph. Cool? And also remember that because of the way this is set up, some of it might not be even, you know what I mean? We're just making lines here and going. Boom, boom. Okay, let's start by graphing this. I'm gonna make this one in black. Y equals 2x. And then we're gonna compare it to the parent function. So when I want to compare stuff to the parent function, I'm always going to graph the parent function, then I'm going to graph my other equation. Then I'm going to compare in words as well. So you compare in graph and you compare in words, understood? So if I'm graphing the parent function, what do we know the parent function is? How do I graph the parent function? Y equals x. What's your y-intercept? 0. What's my slope? So here's my parent function, right? I'm going like this. Okay, so my parent function is this equation right here. And I personally just use other colors, and you can do the same on your homework. Or do it all in pencil and then highlight it in a different color, okay? If you color code your stuff for me, then you don't have to label this y equals x and like make it on the graph so that it looks messy, you know what I'm saying? Okay, so my suggestion is use different colors. So my parent function is y equals x. Now, I want to graph y equals 2x. What do you think is going to be the difference between these two before we even graph them? What's happening to them? Do they have the same y-intercept? Yes, they do. Because this has nothing added to it, so what's the y-intercept still? 0. Only time the y-intercept changes is if something's added to it. Not multiplied, added. Okay?
Yeah.
So my y-intercept is still 0, 0. Now, what happened here compared to here? What changed in those two equations? The slope, good, the slope. And my slope is up 2 over 1, right? Rise over run. So up 2 over 1, up 2 over 1. I can also go down 2 and over 1 this way. So this now is the equation of that. Now, that shows me a comparison on a graph. Use words for me. How did this graph change compared to the parent function? It's very simple. Okay, doubled the rise. Oh, you can just say that. Another way that we're gonna word this is we're going to say, it did double the rise, but we're gonna say that, okay, we're gonna say that the slope, sort of, you're on the right track. We're just gonna say that the slope increased by 2 units, or the slope changed by a unit of 2, okay? So if we can describe it in that form, that the slope changes, then we'll be okay. Does that make sense? Okay. In your book, it says, the graphs of y equal 2x and y equal x both have y-intercepts of 0, but the graph of y equals 2x has a slope of 2 instead of 1. Okay? So this is a slope of 2 instead of 1. Now, we're gonna also do this one and compare it to the parent function. Okay. What is different about this one right off the bat?
It has slope-intercept.
Well, they're
I'm at
all
Y- I'm at Y
y-intercept. It has a y-intercept, yes, it has a b. What is my y-intercept in this case? 3.
3.
So, I need to start by graphing a point on 0, 3. Okay? My y-intercept is 3, I'm gonna graph on 0, 3. 1, 2, 3. So my y-intercept, I can't talk, shifted up 3 units. Now, what slope do I have? 1, so I still just go up 1 over 1, up 1 over 1, right? And I can go down 1 over 1. And here's this equation, yes? Now, we compared it on a graph. Tell me in words. What? Yeah, tell me in words comparison. Perfect.
Let's go. So smart.
The y-intercept shifted 3 units up. Okay, so on your homework, when your homework says, compare the graph, yes,
Do you know who's working Chick-fil-A for lunch?
for high school?
Yeah.
Yeah.
There's a list of people that
Uh-huh.
have ordered. They put the names on the thing. They just need to know that they can
Perfect.
print this out.
Awesome, perfect. So when you do this on your homework, like I was saying, you're going to graph it for me, graph the parent function, graph the function it wants compared to it, and you're giving me words. Even if it doesn't say that in the directions, you are doing both always, understood? Words and graphing, words and graphing,
That's bad.
because you don't want to do the words, I already know.
Can I get an
So, questions on this so far? Any questions on how I did this or what's going on? We're okay? Okay, slope-intercept form. If you write equations like we had, y equals 2x, okay? It's in slope-intercept form because we could just add a 0 to it and that's my y-intercept. So don't let that confuse you, okay? It's in slope-intercept form. Using slope-intercept form to graph an equation, okay? First, you write the equation in slope-intercept form, meaning everything is set equal to y. So if it's not in that form already, we've got to get it set equal to y. Part 2 is you identify the y-intercept, the b. My y-intercept, my y-intercept, my y-intercept, okay? And you plot that point. Cool? After you plot that point, step 3 is to identify what the slope is. That's what's in front of my x, a 1, a 4, a 7, a whatever. You identify the slope, a half, a negative. I know, Stephanie, I got it. Thanks. Okay, so you plot a second point on the line. And step 4, you draw a line through the 2 points, period. So we're making graphing easier today than actually plugging in 5 points on a chart and doing it, okay? We're just gonna go simplified with graphing lines. Can you handle those steps? Which is what I just exemplified to you, and what I'm going to exemplify again a couple more times. What, Kaden?
Nothing.
Elle, are you, keep going. Are you sure you got it? Okay, you're not like your sister, you can remember things.
That was me.
That wasn't, I love her. She's like, just pause for a minute. I'm like, Okay, now we are going to graph this lovely equation. Now, looking at this equation, I can tell you several things from it, okay? One, I can tell you this equation has a negative slope, meaning which way should my line be going?
Down.
Down, it should be falling. I can tell you that I have a y-intercept that is not 0. What is it? -1. Beautiful. And I can tell you that my slope is a fraction, right? So I can do a lot with this, to be honest, which is exciting for me. Okay, so let's start by graphing what we know. We first have to identify the y-intercept, correct? So what is my y-intercept? So I graph a point at -1. Now, I identify my slope. What is my slope? -2/3. This is my slope right here, yes? So I'm going down 2 over 3. 1, 2, 3. There's my point. I can also reverse this, and I can go up 2 and over 3 this way to graph another point. Does that make sense, what I just did? Okay? And then what is my final step? Draw the line. Play connect the dots. You guys ever
I'm
connect the dots?
so bad at those.
Oh.
So I had to push it.
Okay, now I'm throwing in a little bonus question here. Tell me how this compares to a parent graph. Tell me the things that are different with this than a parent graph. Okay, what does it go through instead?
It goes through -1.
So your y-intercept is changed to -1. Okay, what else is going on in this that doesn't happen in a parent graph?
Along.
Okay, the slope has changed to 2/3. And what else? It's negative, so it's flipped, right? Okay, so you have a flipped part of your graph, you have a different slope, and you have a different y-intercept, okay? We gotta start thinking that way. Okay, word problem. The body length y in inches of a walrus calf can be modeled by y = 5x + 42, where x is the calf's age in months. Graph the equation, describe what the slope and y-intercept represent in this situation, and use the graph to estimate the body length of a calf that is 10 months old. So if I want to do this, where do you think I'm going to start? Start with this equation. So my equation says y = 5x + 42, correct? 42 is what in this case? Your y-intercept, awesome, it's my y-intercept, right? Okay, so I'm gonna count by, I just put 10 up there, I'm gonna count by, let's count by tens, okay? It'll make it easier for me. So this is gonna be 10, and I have a question, do I have to count by tens here and count by tens there?
No.
No, I can do whatever the heck I want, which is nice.
Bing bong.
Okay, so it's gonna be at 42, right, is my y-intercept, so it's someplace like right about here, yeah? Now, what is my rise and run? What's my slope? 5 units, Kaden? Yeah. So you know what, I'm just gonna count by 5 somewhere here, because it makes it easier in my life. You get what I'm saying? So it's up 5, yeah, it's up 5 over 1, it's up 5 over 1. So if I'm at 42, I go to 47, right? And then I go over 1. And then I go up to 52, right? 47 and 5 is 52. And I go over 1. So my graph is pretty like standard, like right there, okay? So this is my thing for my walrus. Of course, I'm not going to have an arrow that continues through here because it started at 42 as my y-intercept, so there's a stopping point.
When someone eats it.
Okay, so that's the equation of what that line looks like thus far, okay? Then it says, describe what the slope and y-intercept represent in this situation. What does the y-intercept represent in this situation? What would I label this y-axis? Body length? Body length in inches. So this represents body length. So I would label this side body length, right? Oops. It's gonna look weird because I'm writing. this represent down here?
In months,
In what?
months.
Months, good. This is my age, and this is the months. So, don't forget that I need labels on our graphs, especially when they're real world scenarios, okay? When we're just graphing like lines and stuff, you don't need a label clearly. It's X and Y axes, got it. But when it's real world stitch, okay? Use the graph to estimate the body length of a calf that is 10 months old. So I would go to 10 months old, right? Which is like approximately here. And if this was on graph paper, it would look better and make more sense. And I would come up to here, and I'd come and make a little dot, and I'd come over, and we would estimate what it was. Now, I'm gonna tell you mine is way off probably, because my graph is not accurate, okay? It is way off, I will tell you. So let's plug 10 in and see what it is, okay? If I'm plugging in 10, does that go into the X or the Y? The X. So Y equals 5 times 10. When you do this on graphing paper, like I said, you will have boxes, so it will be easier. Use a ruler and just draw your lines and see where it crosses, and then you say approximately whatever. 5 times 10 is 50. 50 plus 42 is 92. So approximately at month 10, it will be 92 inches long in body length. Cool? Okay? Does that make sense? Can we handle applying it to real world situations? Cool. Standard form. Now, standard form of an equation is ax plus by equals c. Okay? Do you remember that? Like when you use Pythagorean theorem, you have like a squared plus b squared equals c. Okay? So those are called standard forms. A standard form is ax plus by equals c. Problem is, I can't graph out of standard form. What can I graph out of? Y equals mx plus b. So if I rearrange the standard form of an equation into y equals form, I can then graph it. Okay? So I'm going to write the equation in standard form when I'm using it to graph. Okay? I can do it one of two ways. If I write the equation in standard form, then I need to identify the x-intercepts. Do you remember doing this when you were, in math 8 maybe? And you would plug 0 in for y to figure out what x-intercept is, and then you would plug 0 in for x to figure out what the y-intercept is, and then you have 2 points and you draw a line through them. So when it is in standard form, instead of rearranging it to put it in y equals form, just plug a 0 in for x, plug a 0 in for y, and graph the 2 points and make a line. Okay? It saves you work than rearranging an equation, and possibly ending up with fractions where you don't want to have those, and you just like to make your life simple, right? So if it is in standard form, just plug zeros in and solve, okay? So, if I have 5x plus 2y equals 10, let me readjust this a bit. Maybe. Let me click on this. Okay, so if I have 5x plus 2y equals 10, okay? Let's say I want to graph this, because that's what it's telling me. See how you're going to have lots of fun stuff to graph all year. This is going to be your favorite class, I can tell. Elle, you should be grateful. You were wanting to get back into this.
I'm grateful that we're back too.
Okay, so if I want to graph 5x plus 2y equals 10, instead of rearranging it to put it in y equals form, let's just plug a 0 into x and figure out what y is, and plug a 0 into y and figure out what x is. Make sense? Okay, so if I do that, I have 5 times 0 plus 2y equals 10. What happens there? This becomes 0, and I have 2y equals 10, which means y equals 5. So my solution point is 0, 5. Yes? 0, 5. 1, 2, 3, 4, 5. 0, 5. Does that make sense so far? Now, if I plug in 0 to y, I have 5x plus 2 times 0 equals, I'm too high. There we go. Equals 10. So I get 5x equals 10, which means x equals 2. So my point is 2, 0. I come over here to 2, 0. Now what do? Get a straight edge and draw a line through there. That's why I need a straight edge, because I can't draw straight lines. Can you graph that way? Yes, we can graph that way. In fact, we like graphing that way. That's probably one of the easiest ways to graph. So tonight's graphing stuff, even though you're gonna have several problems, shouldn't take you super long because you're not making any charts on these. You're plugging in zeros or it's already in y-intercept form and you're graphing the y-intercept and the slope, okay? Can I switch slides? How are we doing? Okay, I got two left. This one talks about horizontal and vertical lines, okay? If you have a graph that says y equals and it's just a number, you have a horizontal line. If you have a graph and it says x equals and it's just a number, there's no x like y over there or anything, it's a vertical line. So y equals gives me horizontal, x equals gives me vertical. Okay? And the last slide is graphing those two things. If I have y equals 2, how do I graph y equals 2? Well, it's pretty simple. I come up here to y equals 2 and I graph a horizontal line. Does that make sense? And if I have x equals -3, I come over here. Oops, that's not negative. I come over here to -3 and I graph a vertical line.
I feel this every single time.
Okay, because it's all the solutions for x at -3. It's all the solutions for y at 2. Okay? That's what we're working on tonight. Anna Cat, can you hit the video for me, please? And that shouldn't be too difficult.